Thank you for watching Knowledge Academy. This is a very big topic again, lines and planes in space. Lines and planes in space. So really the thing is space is a big topic or big scope. Space could be anything. Your room is a space. Your room is a space, right? And this planet Earth is a space, right? This whole universe is a space. So let's suppose I draw a little curve inside your room. You have a little room, and I draw a, you make a, how basically I'm just want to know how big is the fan look like in your room? How big is the fan look like in your room? So draw this fan, and I take this space from room and go to the space, right? I go to Jupiter. Jupiter is here, big planet, and I just try to make the fan here. And I make the fan here. Yeah, this fan is basically look like not even a dot. you know so there is a lot of variation in sizes, a lot of variation in sizes. So in order to variation in sizes, what I do, rather than I just use meter, 1 meter and 1 kilometer, I start using a arbitrary number. I says 1t, 1t, and this t is parameters called parameters. So your grade usually you have, let's suppose, is a great example is that you have a grade. So you usually have a grades from 0. You can go as minimum as 0. I don't think so any professor gave you negative grades, but the minimum you can get 0. And if you want to get maximum, yeah, that's another question. Some assignment is 100 points, some assignment is 70 points, some assignment is 10 points, or 1,000 points course. So the point is that these guys keep changing. So the size variation is here. So rather than I can say, you know, your assignment is based on this, I can say your assignment is go from 0t to 1t. Now this t could be anything. You say in this case t is 100, in this case t is 70, in this case t is 1,000. If you have assignment, let's suppose 35 points assignment, you take t and then 35. Okay, and that's one thing. So what I do, I have a curve like this, and I have a curve like this. I can split this curve in an equation. In an equation, I'm just jumping into the topic. I'm going to take this equation. I'm going to take the equation of this curve, right? The equation of this curve. When I say equation in this curve, I'm going to be writing, whatever x equals to whatever, y equals to whatever. Same thing, x equals to whatever, y equals to whatever. So rather than I just write here 2y squared plus 1, blah, 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 I just start mentioning them into a t form, into a t form. So maybe I says, x equals to t minus 1, y equals to 2t squared plus 1. So think about it. If I start giving you these equation in t form is amazing. You just change the value of t, you change both x and y value. So really the bottom line is my equation does not depend on x and y, but my both equation depends on t. So equation in t form called parametric equation. Parametric equation. Okay. Let's jumping into that and talk about what the heck these equations are and how do we develop them. Really, you don't have to remember or able to prove where these equations came from, but at least you know what's the origin for those equations, where they came from. So I'm going to say it's parametric equation. of line. So I'm going to understand them through line and then move into curve. My goal is to do parametric equation of line, then curve, and then go to surfaces. Line, curve, surfaces, line, curve, surfaces. So I'm going to do T from lines, T from curve, and then T from surfaces. One by one, that's our goal this week. So if I have an equation called a PQ, right? It's a straight line equation. So maybe I can say, you know what, just do 3D, not 2D anymore. It's a vector calculus, just jumping into 3D. I have a line. One is P, one is Q. Does line is in a space? Yes, definitely in space. It's a room. I don't know. Maybe it's your bathroom, your room, or maybe you are talking about a space between Earth and Jupiter. It's a gigantic space, right? So I don't know how big is this PQ, to be honest. What is the size? Is 1 mile, 1 million mile, 1 billion miles long PQ? I don't know. And I don't care because I'm using parametric equation. So what I'm going to do, I'm going to be just typing some coordinate x1, y1, z1. The other one I'm going to call xyz. In order to do this parametric equation, what I'm going to do, I'm going to make another vector which is parallel to this line. And I'm going to call this vector maybe v, right? Since v is a vector, I can write maybe this vector like this. It's a vector, I can write like this. Yes. We have 3 coordinates, 1, 2, 3. A, B, C are the coordinates. I'm going to say v is parallel to PQ. Or if I want to say just PQ, should be sufficient because PQ is a line. So V is parallel to PQ, right? I know I can say scalar multiple. Scalar multiplier. So what does that mean? I take line PQ, right? And I'm going to take this distance from here to there, the distance, maybe whatever, T, right? If this distance is T, so what I'm going to do, I'm going to take this T multiplied by V. So I should be able to getting this multiplier. Or if I have another multiplier, I say, you know what, this vector v is 5 times bigger than this or smaller than this PQ. So maybe this line says 1, 2, 3, 4, 5, and one of the p's equals to this v vector. So if I take this v vector and multiply by 5, I should be able to get this. Okay, and that's what we learned from in our previous topics. So I'm going to write PQ equals to T, and that is actually my scalar multiplier. Who my scalar multiplier is really this T. Okay, let's finish this. Here I'm going to be writing PQ. So PQ equals to x minus x1, y minus y1, z minus z1. From the coordinates, I just take the minus and writing this pretty much. That's what we used to write the vector or lines. Then T V can be written like this. AT, since V is ABC, AT, BT, CT. Right? I'm going to take this guy and this guy to make it equivalent, this equivalent to this, this equivalent to this, this equivalent to this. Okay. I'm going to write here x equals to. So just write initially, just write one by one, just the way it's written. X minus x1, AT, y minus y1 is to BT, z minus z1 to C. Okay. I can rearrange them. X equals to x1 plus at, y equals to y1 plus bt, z equals to z1 plus c. That's what you call parametric equation of a line. Line is the key here. It's not a surface, it's a line. It means straight, no degrees. If I want to do another thing here, and maybe I just want to erase a little bit this guy and try to solve on the other side. If I want to do something about this, and I'm going to say, you know what, take t from here. So t equals to x minus x1 over a. If I take the t from the other equation, so they have a three equation, right? Guys, this is a three equation. Number one, number two, number three. The other equation I'm going to say is t equals to y minus y1 over b. T equals to c minus c1 c. T. Can I write like this? I can equivalent them, so I can write like this. I should be able to write like this. I should say. And I'm going to put in a box, and I'm going to call them symmetric equation. Symmetric equation and parametric equation. Interesting. We use parametric equation to develop symmetry, and then we develop symmetric equation. But interesting, I'm going to write here. No t is not. It says no t. Okay, there is not. It's a no t. It means symmetric equation have no even a t. And what exactly symmetric equation means? What exactly symmetric equation means? Every morning you go and then look yourself in the mirror, or at least, wise people say at least saw yourself at least once in a mirror before you go out. So you saw yourself in the mirror, how tall you are, I don't know, maybe 1.7t, maybe 0.6t, I don't know. But if you go to the mirror, you want to see yourself in a mirror. So when you see in a mirror, you see the symmetry of yourself here. If you learn physics about light topic, this is how you know how we make the virtual images or real images. So mirror is the virtual image. And when you try to saw yourself in the mirror, this guy is not even involved. It's just basically a reflection. So you see, these equations are a reflection of each other. So if I make a line here, the reflection will be another line, right? And this is a symmetry. Before moving forward, make sure we understand one thing. We're going to talk about that. This A, B, C are the vector component. This x1, y1, z1 are component of this point. Maybe you want to do something fancy. You say, I don't care about it. I'm going to say x1, y1, z. So you can take these points and you can solve this equation. And again, A, B, C belongs to vector. X1, Y1, Z1 belongs to coordinate. The two coordinates you try to make a line. You can change these coordinates based on any point. So you can take point this one, this one, this one, any point you want to take. Maybe you can take a midpoint and then solve this equation again. So bottom line, some student confused about parametric equation. It means there is a one line could have more than one parametric equation possible. So whatever depends on which point you take, you can develop the equation and go from there. Then you can take any points on PQ to develop the parametric equation, right? You can take any point from PQ to develop the parametric equation. In my case, I take P point. You can take Q, or maybe you take any other point. Maybe you can do midpoint. Take the midpoint of them and then use X1, Y1, Z1 to the midpoint. you can still develop a parametric equation. Okay. Let's take a look another problem. Real fast, we're going to do some problems. Parametric and symmetric equation of a line that passes through, that passes through this is a point and is parallel to B. Yeah. So I'm going to say here, this is my x1, y1, c1. In this problem, I don't even have a choice. Only one point is given, right? Here, A, B, C. Make sure we are very clear about what is a vector A, B, C and x1, C. If you flip-flop them, you cannot flip-flop them. Vector is fixed. A, B, C is a part of the vector. There's nothing you can do about it. Okay. Now what I'm going to do, I'm going to be just simply substitute that since we already know the concept. I'm going to say is x equal to x naught plus at, y equals to y naught plus bt, c equals to c naught plus ct. The reason I'm just writing here naught, some books says naught for x naught, y naught, z naught is a starting point. So if you have, it's more likely x naught, x1, y1, z1 is a little bit different than x naught. X1 is always x naught is always using for a starting point. So you can write like this. But if you don't want to write like naught, you can still use 1, 2, 3. Right? That's what we learned earlier. Right. 1, right? So these are just if you know the concept, these little bit changes depends on the books and author, who should not be bother you. And simple, I'm going to substitute the value is going to be 1 plus 2t, 1 plus 2t, y equals to minus 2 plus 4 from b, t, and then z equals to 4 minus, that is my parametric equation. Okay, let's go to the second part, symmetric equation. So I'm going to say t from here equals to x minus 1 over 2. Simply, I just take the t here, take the x, bring the 1 on the other side, and divide it by 2. That's my x. That's my t value here. T from this equation equals to y plus 2 over 4. T equals to c minus 4 over minus. All I can do is just eliminate the t and then write it like this. X minus 1 over 2, y plus 2 over 4, z minus. That is my symmetric equation. Let's take a look another problem. Okay, the next one. Let's take a look another problem. Find the parametric and symmetric equation. Find symmetric and parametric equation of the line that passes through the points. This time I have a little bit different scenario. I have to watch what I'm doing. And 2 points are given. But before we start, in this problem, you notice one thing. I write symmetric and parametric equation. I cannot find symmetric without parametric, so I have to find the parametric before I do the symmetric. But there's a 2 points are given. Our points is -2, 1, 0, and then 1, 3, 5. I don't have any v's given. So what I'm going to do, I'm going to take this times this minus them. So I'm going to be writing like this. 1 minus -2, 3 minus 1, and then 0 minus 5. Okay. 5 minus 2, 5 minus 0. And I'm going to be just putting into this parenthesis because this is a vector. And I'm going to call it. Why do I call it V and then you confuse? But what I'm going to do, I'm going to be just explain this to you. And what I'm going to be writing, I'm going to be writing like this: 3 vector, 2 vector, 5. So really, I'm going to be taking red color, try to draw this vector. I'm just trying to find, this is a vector like this. And all I can do, take this vector and multiply by 1, right? Whatever vector you got, maybe you can call P dash, Q dash, P dash, and Q dash. So you can call P prime, Q prime vector. You take it, and then what you're going to do, you just multiply with 1, and that gave you V. So really, that's how I found V. I just make it arbitrary. So remember in earlier when we talk about the discussion of this topic, I have a vector line here, and I make the vector here. But I never told you how far is this distance. It could be 5, it could be 6, it could be 1 million, it could be 1. Right? In this case, I'm just using 1, so maybe this vector is moved 1 unit away. Okay. And we can start our process since we already know all these things. So we can just jump in and say x equals to x naught plus at. So I can pick any point. Maybe I can pick, this is called my x naught, y naught, and that is my a, b, c. All I can do to substitute the value, -2 plus 3t, y equals to 1 plus 2t, z equals to 5t, since we have no c. Z naught. Z naught is 0. Okay, we got this one. That's my symmetric equation, a parametric equation. I want to do my symmetric equation. And it's going to be x plus t over 3, y 1 minus 1, 2, c 5. That is my symmetric equation. Let's take a look at another problem. Now maybe you want to do a problem where line, find the question you're going to be doing for yourself. Find symmetric and parametric equation of line that passes through. So remember what I'm doing right now. Pay attention, I did not use other parentheses. I'm using these parentheses because I'm talking about coordinates, not talking about vector. And that is your homework problem. If you want to practice something, make sure you got this thing straight. There will be more than one answer for these equations, so don't be confused or surprised if you saw more than one answer. Let me jump into a little bit on another topic. Now I'm going to be talking about planes in lines in space. So there is one line, there is another line, like line 2, line 1. I combine these two lines. I say line 1 is this way, line 2 is this way. You can find the equation for this. You find the equation of this. You can extend this, you can extend this, and you make a surface and you call them plane. Plane, straight. Plane cannot be bent, straight. Always like this, always like this. Right? These are the plane 1, plane 2, maybe plane 3. All three planes are straight. So I need to find out equation line in space. Now plane in space, it's going to be look like pretty much like this. Y, X, Z, and I'm making like so this n vector, this vector n should be another color, and n is perpendicular to this plane, and this is called normal vector. And I have another vector. So really think about it. If I take this line called PQ, which is pretty much what we learned PQ lines earlier, and then making normal vector n on the top of any point, maybe here, and we try to extract the line. So really I have a line here, and somebody asking me make a plane from this line, so I can just do one thing. I take another normal vector, maybe somewhere here, and then dot it, and then combine this is 90 degree and call n, and this line maybe I can call something, but maybe the point is very important. I need a point on a line. So let's think about it. I can make a point. You can make a plane like this. You can make a plane like this. You can make a plane like this. Every plane I make 3 plane have this point common. Okay, this is exactly what I'm saying. You need in order to make a plane, you need a point and direction. All you need is a plane, a point, and which way you want to make the plane. I want to make a plane which is 90 degree to this end. Okay, no problem. Just go here. You make a plane and you see it's 90 degree. I ask you, hey, you know what? I want to make a plane. You says, well, give me the point, give me the normal. I says, point is same. This time normal is this. This time what you're gonna do, you're gonna go here, you're making a plane, white color plane, and this guy is again, this plane is just like this, is 90 degrees. So basically all you need is n and point, direction of the vector. Okay, so what are you gonna do? You're gonna just make it short. So I'm gonna write like dot product. If two vectors are perpendicular, PQ, this one PQ, so I says PQ is perpendicular to n, but n is a vector, PQ is also a vector. If both are perpendicular, their product dot product should be equal to, if two vectors are perpendicular, their dot product equals to
0.
0, right? And that's exactly we're going to take the advantage of and then write it like this: A, B, C dot x minus x1, y minus y1, and it's coming on my way, so it should be gone. C minus C. Okay. Oops. Now I can rearrange this one: x minus x1 plus y minus y1 equals C minus C to 0. And in fact, that is pretty much my equation of plane that passes through a point and normal to a vector for ABC. Well, general equation of a plane. Important part is that here, make sure you guys always including this equation always have something here, maybe constant, maybe zero, maybe whatever, but you must make sure you adding this into your answer. Okay. I'm going to do one example and then wrap up this one. Let's take a look at another problem. Find the general form of equation. Find the general form of equation. The plane that passes through one, 3, 6, and perpendicular to n minus 3i plus 2j plus k. Okay, let's do ABC real quick. A, B, C. And this one is x1, y1, C. No solution. All I know from previous slide is my equation x equals to x minus x1 b plus y minus y1 plus c z minus z1. So what I'm going to do, I'm going to substitute the value equals to 0. So let's substitute the value minus 3 x minus 1 plus 2 y minus 3 plus c 6 equal to 0, and minus 3x plus 3 plus 2y minus 6 plus c minus 6 equal to 0, minus 3x plus 2y and then plus c, and then I'm going to take 3, this, and it's going to be minus 12, and minus 12 plus 3 will be minus 12 plus 3 will be minus 9 equal to 0. This is my equation of plane. Let's take a look at another problem. So last time we talked about how can we just determine a equation of a plane which is normal is given, and the thing is that it's just like that, and I want the equation of this plane and a normal is given here, and this normal have three vectors a, b, c, these component, and the standard equation we learned here is a x minus x1 plus b x y minus y1 plus c minus c equal to 0. This is one of them. We did the problems of those. Now, what you're going to do today, you're going to be moving a little bit our format, and we're going to talk about a different way how we can determine the plane. Okay, plane in space, which is 3 points are given. So in order to find the equation of the plane while only 3 vertices are given, is going to be finding the equation of a plane given 3 points. Yeah. And what exactly is given is we have 3 points are given. Yeah. It could be other way. It could be 3 points are given. See, the way I'm drawing these lines is very important. Now, if I have 3 points are given, I can name them P, Q, R. Can also do P, Q, R. I can do one more thing. I can put the arrows here. One arrow from PQ, one arrow from PR, another arrow, same thing here, PQ, and so I can make these vectors. PQ is a vector. Okay. We also learned another thing previously in our cross product that if I have a PQ and PR, PQ and PR, two vectors. And if I do this, PQ cross PR, like basically cross product, I'll find a vector. I will find here a vector. And that vector is n. And basically this n means it's normal to PQ and PR, both on PQ and PR. And what exactly is that? If I want to draw the vector here, it's going to be maybe normal to us. So maybe towards us. Maybe towards us, I can just make it towards us. Here, if I have a vector like this is my x, y, z axes, is going to be on the. So if you see from here, yeah, let's suppose that's your eye. You see from here, you're going to be seeing from a line, and there is a normal vector. This line could be PQ, could be PR, whatever. Okay. So if I'm going to draw one more time, if you have like a, let's suppose you have a plane. Yeah. So you have PQ and PR. These are the, so I'm talking about this plane. And the normal vector would be look like what axis is going to be along z axis, so it's going to be this axis. Okay, and that is a normal vector. So what are you going to do? We're going to do one problem to wrap up this topic. Example. Finding the general equation of a plane that passes through these 3 points, P, Q, R. Either points are given or you determine your own coordinates, right? The coordinates are given, you just name them according PQR or STY, whatever name is there is not necessary. These names are important. Okay. These are the 3 things you've given. So what I'm going to do, I'm going to find the PQ and PR and make them 2 vectors. So I'm going to say 0 minus 2. So I want to call maybe P this, Q this, R this. So 0 minus 2 will be minus 2, comma 3. 4 minus 1 is 3. And minus 1 is 0. Same thing here is going to be minus 4, minus 2, minus, going to be minus 4, and comma 0, comma 5. No, it's going to be 3. Already, we got these two things. In order to find the normal of PQ is like this normal, all I can do is I'm going to find N equal to, I have to take the cross product, I, J, K, and 2 with minus sign, 3, 0, 4 with minus sign, 0, and 3. And we need to do it, so it's going to be 9. If I want to solve it, it's going to be 9i. 3 minus 3 times 3 is 9i. And then J for J is going to be minus 6. Minus 6. And there's a minus 6 with minus sign from the formula, so it's going to be J minus 6J. Okay, and then plus, and is going to be minus 12. Okay, if I little bit simplify it, there's going to be 9i plus 6j, right? 9i plus 6j plus 12k. It's going to be, it is a minus. This should be minus. It's going to be j. So 12, and there is a minus sign from the formula is here too, right? Plus. Okay, I got everything here. All I have to do, I have to say something here. I'm going to say this one is my A, one is my B, this one is my C. And pretty much you're going to use the same equation. A x minus x1 plus B, y minus y1 plus C, C minus C. Now here's a caveat. A, B, C are there. Now you can take this point as your x1, y1, z1, x1, y1, z1, or you can take this one x1, y1, z1. You can take also x1, y1, z1. Either one, you can take it. So you have three different kind of equation probably gonna come out, but all three equations are correct because parametric equation is sensitive based on the normal vector, not the coordinate. Okay, normal vector playing role, not the uh, coordinates, because plane really doesn't have any size. Any plane does not have really any size. Plane is infinite. So infinite plane. Plane size does not matter. A x minus 7. I'm just using the point. Uh, so I'm using P point, at least this point for my standard point P plus 6 y minus 1 plus 12 z minus 1. I have to simplify. I cannot leave it. So I'm going to multiply these two. So what I did, I just multiply x, y, z like that, and then solve the rest of them. So it's going to be minus 18, minus 6, minus 24, and minus 24, and then minus 12, minus 36 look like. Can I simplify this equation further? Probably yes. I can divide it by 3. So it's going to be 3x plus 2y plus 4z minus 12. And then Okay, let's move on to another way we look into those planes. So I'm going to say is finding the angle between two planes. Okay, finding the angle between two planes. And the formula is pretty simple. But let's talk about the concept. The concept is if I have a plane like this, you know, to draw some other way so we can see the normals. So I have a plane like this, and this is a plane one, and the normal would be this. And I have another plane like this. I'm going to make another normal, which is 90 degree to this. So I'm going to call N2, N1, P2, and then P1. So really this plane making 90 degree here, 90 degree here with these normals. And what exactly I want the angle between the two. So really maybe I want this angle, or maybe I want that angle. This both angles should be same, and that is my theta, right? That is my theta. The way I'm going to be writing here is I'm going to say cos theta equal to n1, because n is a vector, dot n2, right? I'm not interested in the magnitude direction. I'm only interested in magnitude value. So I'm going to be writing like this, and we're going to take the magnitude. And really what I'm doing right now is nothing but just dot product between them. I'm really taking the dot product between n1 and n2, and that's what I can do. Okay? So let's take a look what we can do. Say a problem here. Find the angle between the two planes given by x minus 2y plus z equal to 0, and the other one is let me just do it, 2x plus 3y minus 2 is equal to 0. Okay, what are you going to do? We're just going to say n1 and 2 and 1 minus 2 1. I just substitute taking the constant, and that is my ABC for this vector. Other vector also same way, my A, B, C are those. This is 2, by the way, not Z. We're gonna find out the magnitude of N1. Same thing, we're gonna find the magnitude of N2 for our formula. And it's gonna be 1 plus 4 plus 1. So it's gonna be square root of 6. It's going to be 4 plus 9 plus 4. So it's going to be 9 and 8 is 70. We got this. We're going to substitute into our formula like this one. I'm going to say is 6. And if I want to be multiplying, I'm going to be multiplying and then adding there. So it's going to be 2. It's going to be 2 plus minus 6 minus 2. 2 minus 6 is going to be 2 plus minus 6 plus minus 2. All I did, I just multiply the 2. Right? IJK, just like IIJJKK. And what it's going to be is going to be equal to this. And we know that when things are coming out of this mod, we only take the positive value. So it's going to be 6 or something. 17 times 6, so it's going to be 60 and going to be 102, I believe, right? 102. So if we divide this one, we're going to get that equals to cos inverse 6 over 1, 0. Yeah, you guys can calculate that one too and give me the answer. It should be in degrees. Okay. You student confirm is 53.6 something, 55, 56.60. That's pretty much we got. Let's take a look another problem. So the last topic is we're going to be talking about sketch the plane. Sketch plane. Okay. When you want to sketch the plane, all we can do is, let's suppose I have a plane like this, and I write the equation here: 3x plus 9y plus 7z minus 13 equals to 0. Just assume I give you the equation for this plane. This is the equation of this plane, big plane, the plane which is giving like this one. Okay, this plane. And basically it's like a trapeze. It's like a little bit inclined and sitting on the corner. Let's suppose this is your room, the two walls and the floor, and something is sitting on the corner, leaning on the towards the end of the wall, and this is what it looks like. So what you're gonna do when you do a sketch, exactly what you do. You consider this is X, this is Y, this is Z. So all you can do, just this is a plane point, this is a plane, right? You're gonna bring this point down on the floor right here. When you come to the floor and hit the floor, the value of Z here is 0. The value of Z here is 0. And if you try to move towards this end, like this line, the red color line, this end, value of Y equal to 0 because Y here is 0, right? And if you go from this point, you move toward this way, you're going to hit this line, this edge, the value of X equals to 0. So all you can do, just take this equation, substitute Z equals to 0. So you bring down yourself on the down. And then from here, after you get this thing, you substitute X equals to 0. So you're going to move this point and you're going to get this point. And then afterward, you're going to be substituting Y equals to 0 from there. You're going to be getting this one and you're going to be getting this one. And afterward, when you're taking both of these two, you substitute both equals to 0. So if this one is 0, this one is 0, you're going to go up and equal to 0, right? You substitute Y and X equals to 0. So the Z value, you're going to get the maximum. So all you can do is just substituting all three things and getting this maximum value, this maximum value, this maximum value, and connect them together. And that's how you can trace your plane. Okay. When you say trace, trace is usually drawn in a particular axes or particular plane, x, y, y, z, z, x. So I'm going to say sketch the plane. Bx plus y plus 4z equals to 12. Here, I'm going to say x, y, trace. I'm going to set z equal to 0. If I put the z equal to 0 in this equation, it's going to be 3x plus 2y equals to 12. I further elaborate one. I'm going to say is y equals to 0, just like what I here mentioned. Y equals to 0 in this equation, so it's going to be 3x plus 2, 0, and x equals to. So on my xy trace, on maybe this plane, this point, maybe this point, I'm going to get 4, 0, 0, right? So my plane, my point is going to be 4, 0, 0. Same thing what I did, I'm just going to be raise this thing. And really what I'm going to be doing, I want to draw my plane like this one. I don't know how does it look like. So I'm going to be drawing like this. And it goes to 4. So I'm going to say 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 5, 6. 1, 2, 3, 4, 5, 6. If I want to go to negative, I can if I have to. I don't know yet. To be honest, I don't know yet. The other one is going to be doing 3, x equals to 0. Right? The other one is going to be x equals to 0. So I'm going to put x equals to 0 plus 2y equals to 12. And from here, I'm going to say y equals to 6. And my trace point would be 0, 6, 0. So let me do this point first. I'm going to maybe call A, B. So A should be here 1, 2, 3, 4. That is my A point. 4, 0, 0. B point 0, 6, 0. So 1, 2, 3, 4, 5, 6. B 0, 6, 0. Let's do the z when I substitute both equals to 0. So 3, 0 plus 2, 0 and plus 4z equals to 12. And from here I can say z equals to 3. So my point will be 0, 0. Yeah, I'm going to draw this point 2, 1, 2, 3. It's going to be C point, C, 0, 0. And all I can do is just connect these two, connect these two, connect those two. And I got my plane. That is my. Yeah. Another thing we're going to look into that, which is called distance between point and plane. And what is the distance between point and plane? Is you have this plane, and I have one point here, one point here, of P1, P2. Distance always the shortest. Distance always the shortest gap. So I'm going to be making between the plane. I'm going to be just drawing this. That is my T1, and I'm going to be making this. This is my distance. So really, how I can calculate these things. And that is a formula for this distance between point and plane. It's nothing but it's just a dot product again, because you know these two lines making an angle 90 degree. And that's what we use to do that. So I'm going to say is PQ, my vector, which is just normal vector, dot N. n is the normal for the plane, right? So PQ and maybe QR, this is PQ and QR. So PQ and Q are different, but n is n for pretty much both planes because you know the normal of the plane is one, only one, okay? And n, where P is the point in the plane and n is a normal. Yeah, I would say normal vector. So let me just do one problem. If you can go to the next slide and do one problem real quick. Let's take a look at another problem. Find the distance between the point any point is given in the given plane by 3x minus y plus 2z equal to 6. So both are given. And I'm going to go and then solve it. So first I need to find the n, right? And n is nothing but it's just basically a could be a vector. So what I'm going to take the plane and do a by c. And from here I'm going to say 3 minus 1, 2. One student asking me how can I get these things, professor? So it's basically going to be like a x minus x1 plus b y minus y1 plus c z minus z1, right? These kind of thing. So what I did, I just take these a, b, c from this, and that is how my constant looks like, my ABC look like, or finding out those. And here it's going to be 9 plus 1 plus 4, so it's going to be 14, right? Now what I'm going to do, I'm going to set, I need a point, right? So in the plane, I have a point here, which is maybe the equation given for our for the line. All I have this point is given, which is maybe Q. I can call it Q, but I need a point here. So what I'm going to do, I'm going to take the plane, like normal vector somewhere, and I need to find out this. So what I'm going to do, I'm going to substituting x. It's not, I'm sorry, x, y and z both equal to 0 to bring it down, right, to finding the point. So in order to find p, q, I need this point coordinate. P is not given, right? So what I'm going to do is p set y equals to 0 and z equals to 0 from the equation. So 3x equal to 6. From here, x 0 and then 2 and then 0, 0, right? So really this is my point and I need to find PQ. Q is given. And what is the Q? 1. So 1 minus 2, I'm going to do PQ. So this is my Q, this is my P. And I'm going to do this. So 1 minus 2 is going to be minus 1 and 5 and minus 4. Okay. And nothing but is just do distance. The formula was this. I need the magnitude of this divided by n, and it's my 14. Here is the magnitude of this is going to be 25, right? Basically, it's going to be pq dot n So I'm going to multiplying the two. So 1 plus minus 1 plus 25, and then 1, p, q, and n. Okay. So I'm going to take this vector and then pq, I'm going to take it's going to be 1, 3, minus 3, minus 5, and minus 8, right? So it's going to be minus 16. Well, 2, if I take it out, it's going to be 16 or 4. And pretty much you can simplify that assignment. It doesn't like this one. You have to give in the decimal, but pretty much this is my answer. You can change the format, but it's not going to change much. Thank you for watching Knowledge Academy.